So today I am going to present a seminar on basic topic of enzymes. So by definition, enzymes are the biocatalyst which is actually catalyzing the rate of the chemical reaction, but the enzyme molecule itself remains unchanged during these chemical reactions. So how the enzyme molecule is actually catalyzing the reactions? In the normal chemical reaction, this is the reactant side and this is the product side. So the reactant, first its activation energy is increased and then it goes to the product side. So enzyme, it is actually reducing the activation energy. So by reducing the activation energy, the enzyme catalyzes the reaction. So enzyme actually increases or speeds up the rates of the reaction. Now the properties of the enzymes are, it has high efficiency, it produces chemical reactions at very faster rate is 10 to the power 3 to 10 to the power 17, and the enzyme molecule, it has very much specificity, that is the enzyme molecule is very much specific, and reaction conditions are very mild, that means at normal room temperature the reaction can be occurred. Now the chemical composition of the enzyme molecule is that it may be either a simple protein or conjugated protein. So the conjugated protein, which is actually called a holoenzyme. So holoenzyme is nothing but this is the combination of apoenzyme and cofactor. So cofactors are actually the non-protein part and apoenzyme is the protein part. So they together form the holoenzyme. And coenzyme, these are loosely bound to the enzyme, and prosthetic groups are those which are very tightly or covalently bound to the enzyme. Now classification of the enzyme according to their composition, they are of three types: monomeric enzyme, oligomeric enzyme and multi-enzyme complex. And enzymes, they may be classified according to the type of the reaction they catalyzes. These are oxidoreductases, which is actually doing the oxidation reduction types of reaction; transferases, which does the transfer, which actually transfers the groups of the atoms; hydrolases, which is doing the hydrolysis; liases, which actually add atoms or remove atoms to or from a double bond; isomerase, which rearranges the atoms; and ligases, which use ATP molecule to combine molecules. Now the nomenclature, according to the nomenclature, the enzymes, they are generally termed just after the name of the substrate. The ase term is added. For example, the enzyme which is used to cleave the lactose molecule is termed as lactase. Similarly, the enzyme which is acting on DNA polymers, which will be termed as DNA polymerase. So this is again how the enzyme molecule is acting, just it is lowering the activation energy and it speeds up the rate of the reaction. So again we can see that when the activation energy is high, it is just like a mountain. So to cross the mountain, the barrier is so high, so the rate of the reaction is much more. But compared to the in case of the enzyme catalyzed reaction, where the barrier is lesser, so to overcome the barrier, the energy requirement is less, so the rate of the reaction will be automatically much more. Now the difference between enzyme and protein is that all the enzymes are protein except some RNAs, but not all proteins are enzymes. That means enzymes, they are actually protein molecules, and some of the enzyme molecules are RNAs, but the enzyme molecules by chemical nature, they must be the protein molecules. Now active sites of the enzyme means the substrate, it cannot bind with the enzyme molecule at all places, but it is binding with the enzyme molecule at a particular space which is containing actually the groups which are just it is just able to bind with the groups present on the substrate molecule. So that is called the active sites. So this is the enzyme reactions steps. So first substrate approaches the active site, then enzyme substrate complex are formed, then substrate is transformed into products, the product is released, and the enzyme is recycled. So this is the diagram how the enzyme molecule is acting. This is the active site where the substrate is bound, then this is converted to product, the product is released, and the enzyme molecule, it is returned back intact condition, and it is again recycled, it is again participating or binding with the enzyme substrate molecule to participate in the same reaction. Now the enzyme activity, it is expressed as the moles of substrate that is converted to the product per unit. So it is denoted as the enzyme activity. The factors that are affecting the enzyme activity are concentration of substrate, concentration of enzyme, and temperature, pH, activators just like this, inhibitors just like this. The effect of temperature is that if we gradually increase the rate of the reaction, we will find that if we gradually increase the temperature, we will find that the rate of reaction is gradually increased, and after reaching a particular temperature it will again fall down. That is, this is called the optimum temperature, and after which the denaturation of the enzyme will occur. As a result, the enzyme activity will be reduced. Similarly, the effect of pH, if we gradually change the pH, we will see that after reaching a particular pH, the enzyme activity is gradually reduced due to again the same cause, the denaturation of the enzyme. So this is the effect of pH. Then effect of activator, there are some activator molecules like this metal ions, anions, then organic molecules like the reducing agents, like for example cysteine, glutathione. They are actually reducing or acting as they are actually activating the rate of the reaction. Similarly, there are inhibitor molecules are there which can reduce down the rate of the reaction. So these are the basic ideas of the enzyme molecules. Thank you.